Hi everyone, welcome to this webinar hosted by Quantropi, where we are going to know a lot about Quantropi's doing. And before I go and present and introduce these fantastic speakers today, this event is organized by the Quantum Insider and QURECA. My name is Araceli Venegas Gomez. I'm the founder and CEO of QURECA, Quantum Resources and Careers. And if you're new to Quantum and you would like to know more about this fantastic emerging ecosystem, please come to us. We provide training, recruitment, and professional services. Well, we are going to know today about how to prepare the enterprises for Y2K and the looming quantum threat to cybersecurity. We have heard that quantum computers are going to come and all what we have right now that is very secure, everything is at risk. And that's actually very, very exciting, but also like, what should I do? We have a lot of data. We have a lot of things that we are using that is based on believing that everything that is secure is actually secure. Cybersecurity is a big area, but are we really at risk? Is there a threat coming from quantum computing? We are going to know more about it. So please let me introduce these fantastic speakers today. We have Brian Lenahan. He's the founder, director of the Quantum Strategy Institute. The chair, sorry. Well, I think director is also a good name for you in that case. The Quantum Strategy Institute is an international think tank devoted to the acceleration of the adoption of quantum technologies. Brian is a global pioneer in quantum leadership theory and the commercialization of quantum technologies, consulting to large corporations. He's a 6-time author of books dedicated to the commercial advance of artificial intelligence and quantum technology, including his latest, Quantum Excellence, How Leading Companies are Deploying the Transformational Technology. Well, I think Brian doesn't need an introduction, to be honest. If you are curious about quantum, probably you know Brian. And Michael Reading, he's the Chief Technology Officer of Quantropi. Before joining Quantropi, Mike was Managing Director and co-founder of Accenture Ventures, where he grew a global portfolio of strategic partnerships and 38 equity investments in emerging technology startups. So he knows a lot about what he's talking about. During his nearly 30 years in Accenture, he incubated and launched technology innovations for enterprises across multiple geographies and industries. Ever passionate about bold ideas with game-changing results, he speaks frequently on the impact of emerging technology on large organizations. With a bachelor's degree in electrical engineering and computer science from Princeton and a master in biomedical engineering from Northwestern, so many things, Mike is a former member of the board of directors for the Accenture Foundation and board observer for startups Mana and Splice Machine. I talked too much already. I'm going to go now and leave the floor to these fantastic speakers. I hope you enjoy. You will have the occasion to ask any questions. You will see that on the right-hand side of your screen, you have a chat and a Q&A. You can use both or questions. I will address the Q&A, but I know that you will going to use both. We have experience with these. And you will also see a poll in the middle of this webinar. Michael will address but otherwise you will see that some questions will pop up. Please answer. Sin more ado, please, Ryan, the floor is yours. I'm going to share my screen now. Good.
Okay, thank you very much. Really appreciate the introduction, and I'm thrilled to be here with Quantropi and the Quantum Insider and QURECA. And more so, we're thrilled that you're here because the quantum ecosystem is growing so quickly, and we're now within this webinar addressing one of the most important areas for quantum technologies, quantum information science. So let's get started. So let's move to the next slide. I use the term quantum feasibility, and the reason is because most organizations really want to understand, is quantum technology something that they should be investing in, whether from a time perspective or a resource perspective, a people perspective. And we're going to suggest, and certainly from the Quantum Strategy Institute's perspective, it is very much a imperative that organizations start, if they haven't already, to think about how quantum is going to be included in their business, and or, as we talk about in this section, protecting their business. It's a nascent technology. Certainly, quantum science has been around for over 100 years now, but the Quantum 2.0 where we're actually turning these into devices and hardware and software and algorithms, has a substantial potential, but it's also thinking about how people are thinking about using those quantum inspired algorithms, quantum hybrid technologies today. So we're going to talk about one aspect of that today, but my section here is really about the current state of quantum technologies and where the imperative starts. Certainly, there's no shortage of the number of vendors that are involved in quantum technology today, over 750 different vendors, including those ones that are the very large corporates of Microsoft and its Azure product, Amazon, Bracket, IBM, and so on. Where we're also seeing, and I'll talk about this in the next couple of slides, is the billions that's being invested. But I just want you to remember the overall global investment in IT around the world is in the trillions of dollars. The amount that's going into quantum technologies in the billions, in the double-digit billions, but still a fraction of the overall investment in technology. And we'll see how that plays out. We're hearing terms like you see on the screen, supremacy and advantage and hybrid. Back in 2019, Google identified supremacy in a very narrow lane, but still a milestone to be sure. Then we talk about quantum advantage. How can quantum exceed the conventional or traditional computers' capabilities? And then hybrid, how are these two systems, classical and conventional, going to work together? So it's certainly happening in a much greater environment. However, there are challenges. And what are some of those challenges? Our qubit coherence time, how long we keep coherence in order to keep information with those qubits. What about noise? We're in the noisy intermediate scale quantum era. So how do we think about the noise that's injected, and how do we think about error correcting these errors that are happening in the current era of our capability set? Finally, in terms of complexity, how do you explain quantum capabilities within your C-suite, within your management team, as you access vendors? It's a very complex science, and what level of detail do you really need to get into? And finally, in terms of the maturity of the technology, it's just really beginning in Quantum 2.0. So we have a long runway to go ahead. One of the things that the Quantum Strategy Institute we do is try to balance hype. We are looking for practical solutions for business on an incremental and iterative basis. Let's go to the next slide. One of the things that QURECA, one of our hosts, does very well is provide data elements in terms of what's going on globally. And that's what's shown in this slide. We're seeing that investments are made in the billions of dollars and euros and so on around the world. Certainly some countries are leading, whether it's China, the United States, or areas within Europe, but we're seeing investments being made around the world. The next slide, please. So here we're looking at the annual private investments by region, and you can see over time, especially in the last couple of years, private investments have absolutely escalated. Now, they've been around for 20 years. We see from the very beginning of D-Wave in 1999. But in the last 2 years, those private investments have absolutely blossomed, and in various different areas around the globe, whether it be the Americas or Europe or APAC. The next slide, please. So quarterly investment trends by sector, and this may be a little too small to read, but basically what we're talking about is there are all sorts of industry areas that are being impacted, whether it's finance, chemistry, transportation and logistics, and also in the areas of quantum sensing, quantum communication, and quantum computing. The next slide, please. And these are the number of global quantum companies by founded date. So what you may not see, and what you may have thought would be the case, would be that sort of hockey stick kind of approach on the chart. Well, what's actually happening is we peaked in about 2018, 2019 in terms of the number of companies being found. And again, this data is from the Quantum Insider. But what's happening now more is more capital is being raised, more mergers and acquisitions are occurring. We certainly saw it with the Honeywell and Cambridge activity, but we're seeing a reduction in the number of new companies being founded, but we're seeing increased capital available to the existing companies, and we're also seeing some more startups and spinouts from an academic environment. The next slide, please. So here's where the Quantum Strategy Institute really focuses most of its time, where can quantum technologies, sensing, communication, and computing be applied in the business world? And there's certainly a multitude of those available to us, whether we're talking about chemistry, we're talking about transportation, finance certainly has taken a massive lead in how they're using quantum technologies, whether it be in portfolio optimization or fraud detection or other areas. Certainly each area that, each industry that is functioning today is starting to take a look. You may have seen a report that just came out today from IQM and OpenOcean and Lakestar that talked about how organizations perceive quantum and whether it is something, an opportunity that they're looking to jump into. I'll just give you a couple of stats from that recent report, and you're welcome to see it on LinkedIn from Matt Swain at the Quantum Insider, or look at IQM's website. That 63% of business leaders actually believe that commercialized quantum computing will occur within the next 5 years. Lots of different predictions about when that quantum computing capability will achieve that sort of commercial advantage, but 83% felt that it would happen within the next 10 years, to be sure. 91% of business leaders surveyed already investing or planning to invest in quantum computing, and that sounds like a big number. But we're certainly seeing the large corporates think about quantum and what it means. The last part I would say is that cybersecurity is actually one of the top 3 areas that companies are looking at investing in. And why is that the case? We've certainly seen more activity in the US government and the National Institute of Standards and Technology and their candidacy approach. Organizations truly need to think about crypto agility and quantum resilience in 2022. They need to think about those capabilities as we exist in a harvest now, decrypt later kind of environment. On the slide, we see things like data security and communication, those areas that are vulnerable to data breaches. We see Statista released some data just recently saying that over 25 million records have been exposed in the first 3 quarters of 2022. So we're seeing it on the digital side. But we also need to think forward about how quantum computers are going to create this looming threat over what's happening in the digital space. So when will we see a kind of Y2Q? When will we see quantum computers be able to encode, take a look at those RSA type encryption schemes and crack those schemes in order to grab that data? And is there anything that we can do today to actually address that? And that's what companies are asking. Whenever I'm asked the question, my first question I'm asked is, when will it happen? And the second question is, what does that mean for my data security and my communication security? We're seeing things like QKD implemented in short distance quantum internet capabilities, British Telecom, EY, and Toshiba being an example in London. So we're starting to see some of those communication networks being protected by various types of quantum encryption. We're going to see in the next set of slides that Michael is going to share with you that all is not lost. There are opportunities for corporations and individual companies to start thinking about how they can leverage tools today that will be incrementally improved over the future. Every company needs to think about their crypto agility and quantum resilience starting today. We can go to the next slide. So this is my summary for you. The current state of quantum computing is very much that emerging technology, quantum, is not yet on companies' radar to any great extent. You heard some of the newer numbers from the IQM report, but if you look to downstream towards medium-sized and smaller companies, many can't even tell you what quantum is. When those investments are being made, the investment will be in software, in people, and in services, less so in hardware, which probably makes sense since the hardware is available through the cloud predominantly today. So my final comment here is the quantum imperative is to start now. Investments in understanding where quantum cryptography sits on your roadmap. Again, even if you don't invest $1 today, how can you start thinking about those quantum implications and quantum tools? I'm now going to hand it over to Michael Redding for some insights around what those tools are.
Well, thanks, Brian. Really do appreciate you helping level set us on the excitement, the investment, the advances in quantum compute for good. But I always like to talk about, the inverse, which is, beating plowshares into swords, because of the fact that as you highlighted, what can be used for great purposes, whether business or humanitarian or democracy, can also unfortunately be subverted and used for bad, and that it can be used as a weapon against today's digital infrastructure. And the seeds of that were planted by Peter Shor in the 1990s, where he envisioned a algorithm, which now are series of algorithms, which we now generally refer to loosely as Shor's algorithm, which was great for solving certain mathematical problems when a theoretically large enough and robust enough quantum computer came into existence that would have all kinds of mathematical, machine learning, and data science applications. But unfortunately, those exact same mechanisms would break the encryption at the very heart of today's internet. And that's the old law of unintended consequences. And just as there's new data as of today on people's forecasts on when we're going to have a commercially viable quantum computer for general business use, the question is, when will we have a viable quantum computer as an attacker? And that's harder to know, because obviously when it's being used as a weapon, you tend to find state-sponsored projects that maybe none of us really know about, that they're in a lab in a basement somewhere going on right now. But in this past year, there was, kind of a complimentary survey of cybersecurity experts around the world, over 600 of them. And the consensus was we could see the first demonstration of this form of attack in as little as 2 years. And if we've seen anything in the history of IT about the time it takes to adopt new security or encryption technologies, we're talking often decades. And decades in 2 years aren't compatible, because even if they're wrong by 3 or 4, that's still less than a decade. And so the question becomes, what can we do about it? But first, I'm going to go a little deeper to really put a finer point on the nature of the threat. And so we take a step back, and thanks for advancing the slide. You read my mind. We take a step back and say, for information security purposes, any complete cryptographic system has 3 building blocks, and we use the handy acronym TRUE to keep it in our minds. And that is trust, uncertainty, and entropy. Between any two parties, if you're going to be secure, you first have to establish trust. Who are you? Who am I? Do we know who each other are? Are we trusted? And this is only going to get more important, because one of the hottest trends in information security and enterprise architecture is zero trust architectures, meaning you make trust establishment ever more granular, which in fact, unfortunately, increases the attack surface from a quantum threat. The second building block, once you've established trust, is uncertainty, which means push the uncertainty to the attacker so that the data that is encrypted, whether in storage or in motion, is always encrypted, can never be accessed. And third is, of course, entropy, which is the strong key. Because what's the point of having a strong lock if you have a weak key? It's like having great two-factor authentication, but password 1234, not going to cut it. And so only when all three are quantum strong or quantum resilient is the system quantum resilient. And so we'll use this as a framing device to talk specifically about the nature of the threat. So let's go to the next slide. So today's $50 trillion digital economy around the globe is based on a very simple kind of standardized handshake between parties, between the client and the server. And this is the most simplified version of this very traditional handshake and process, but it shows the primary components, which is to establish communications. You say hello, they say hello back, they share their digital certificate. You use digital signature to say, yes, this is really Brian that I'm talking to. I then get my cryptographic session key, share it through key exchange, right? Move it securely through quantum envelope, or sorry, not yet a classic envelope, got ahead of myself. And then once we both have the same secret, we use that as the encryption key for the actual session data. So hello, verify identity, exchange a key, use the key. Those three steps, that's the internet as we know it today. But if we advance the slide, the attack comes because the quantum attacker, thanks to Shor's algorithm, has a direct ability to break the digital signature, has an ability to break the key mechanism and steal the session key. And through another algorithm called Grover's algorithm, you can actually attack the symmetric session itself. It's not as prominent an attack, and it's going to take longer to be a big threat, but it's coming as well. In fact, interesting enough, my nephew is a computer science student at the University of Michigan taking a quantum computing class, and his class as an exercise implemented Grover's algorithm on a test case. So, the university kids out there, they're already learning how to make this happen. Let's move on. So once you know where the attack's coming, how does it manifest itself? And Brian already hit the nail on the head, steal now, crack later. All I have to do is watch this session that we're doing today, just record it, put it in storage, and when I've got a big enough quantum computer, tear open that envelope, steal the key, watch the video. Last year, 350,000 estimated exchange servers were broken open and exfiltrated to a foreign country where they're sitting waiting for a quantum attack. 99% of those emails is who cares. Some of it is state secrets. Some of it is business. Some of it's political. It has value if that happens even the next 10 years. Second form of attack is because I can attack the digital signature, I can now create fraudulent credentials. I can spoof identity. And you don't know, am I really talking to Brian or someone pretending to be Brian? Am I really Mike or am I someone pretending to be Mike? And so suddenly access to critical infrastructure, to critical systems is in question. And then last but not least, we can go back and literally rewrite history. We can change everything you've ever docu-signed. Every blockchain transaction you've done can be rewritten, can be fraudulently contested, and suddenly you can't know what's true and what's not true. So it's a huge backfile conversion issue to upgrade to something that won't be broken when this quantum attack materializes, but you can't wait for the attack because you just signed a contract yesterday afternoon. Let's move on. So with all this coming and this big transition looming, of course, there's this thought of, I got to get educated. I've got to start to see what tools and technologies are out there. But the reality is, I got a business to run. I got a government agency and I've got to deliver the mission. I can't stop and start over. I can't reboot the internet from scratch and implement an entirely new infrastructure, an entirely new install base, an entirely new cloud. So how can I do this with the money I can afford? Because again, we're on the edge of a recession. The economy's tight. How do I do that with what I've got on hand? And overall, how do I manage risk? Because you don't want the cure to be worse than the disease. You don't want to introduce new risk when you're trying to stamp out existing risk. And so this is what's on everyone's mind. Let's move along. And so, as Brian alluded to already, or even commented on, there's already action being taken. So the good news is no one's just sitting around admiring the problem. Investment and science and startups are getting on this and making things happen. And because the trust element of that digital exchange is what's going to break first, that's where the current effort's going. And so Brian commented briefly on quantum key distribution using entangled photons, brand new infrastructure like BT, Toshiba, and EY did in London to show where I can actually use quantum mechanics to establish key exchange in a way that can never be broken because of you'd have to violate the laws of physics. And that is an exciting building block in this effort to modernize and move forward. But also, as Brian mentioned, our friends at NIST have said, hey, we're going to lead a global effort to come up with algorithmic approaches. So one is infrastructure, one is algorithmic, that says we can come up with new algorithms for key exchange and digital signature that won't be vulnerable to a shores-based or other contemplated quantum attack. And so that is very exciting. And we're going to focus in particular on these digital solutions only because they have a broader utility in that stepwise iterative upgrade that Brian alluded to. So let's go on to the next slide. And mentioning NIST, again, people have been talking about this for a while, but in 2016, they started a formal global process to say, let's get some new digital signatures, let's get some new key exchange mechanisms, and let's fight it out in public. Let's put it through academic rigor. Let's go through multiple rounds of iteration, of challenge and response, and let's make this thing a good enough that we can make it the new standard of the internet. And after a 6-year process, this summer, they actually announced one finalist in key exchange, which is Crystal Kyber, and 3 in digital signature. They also announced a few alternates. Now, you see the little red line, and this is part of the process. One of the ones called Psych, actually, since it was announced as an alternate, was actually broken and since been retracted because they didn't need a quantum computer. They just needed a clever mathematical attack, and whoops. But that's the intent of this process, is it's survival of the fittest. It's algorithmic Darwinism to get us something that will carry us forward. But importantly, you notice they're trying hard not to have it be one, because it comes back to crypto agility. It comes back to the right tool for the job and knowing what we don't know. There's so much undiscovered country in the realm of quantum that we can't say, hey, RSA, good for 50 years. Crystal Kyber, nobody thinks it's going to be good for 50 years. It's going to be good for now, and we're going to have this ongoing mechanism. So this is a fundamental shift in preparedness and being ready to be dynamic. Just like you patch your software on your desktop or your mobile device or your application, we're going to start to learn how to adjust and patch and evolve cryptography as the threat landscape evolves. Let's move on. And so this is a lot of numbers, but the important point is it's not just take someone's word for it that it works. There are tools like NIST's SuperComp framework, and this is getting pretty down deep. But what's important is they're putting out and have now established a way for apples to apples comparisons of different algorithms, different schemes, so that you, and as an IT professional, a systems integrator, a CIO, a CISO, can now start to appreciate things like key size, which goes towards performance and storage and network, as well as CPU cycles. How long does it take to do something, which may be great in a cloud, but not so great on an edge device, because it's going to be agility, right tool for the job, not one size fits all. And so for a lot of organizations, starting to add these vocabulary, these attributes into your lexicon, the speeds and feeds, the same way you think about network routers and CPUs, you now are going to have to think about in terms of encryption. And yeah, it's a little bit more complexity, but but the great news is you don't got to figure it out for yourself. These frameworks are out there. It's open source. You can download it. You can benchmark in your own real world environment. All of this is helping to advance the preparedness and the awareness and the sophistication of the market as a whole. Let's move on. So the other component is, and it was in one of Brian's slides for the eagle eyes, they saw QRNG, because going back to entropy, it's one thing to fix the algorithms, but it's another thing to make sure you've got a great start, which is a great key. And a great key comes from a truly random number that nobody can guess and nobody can factor. And really now we're starting to see the birth of two classes of random number generators, back to agility, right tool for the job, hardware random number generators, often from a true quantum source, some quantum phenomena like radioactive decay or noise of the universe or photon behaviors. And the net result is it's so random because it's just no one can predict when an atom's going to decay, that it gives you this beautiful font of raw numbers that can then be forged into the keys that will protect and make the algorithms we're talking about so much stronger. And then there's times when, especially in the short term, you're not going to have a hardware, quantum source on your iPhone. We can get into pseudo random number generators, completely algorithmic, but they're using an algorithm in order to generate locally the random number, the key you need, maybe for a temporary session, maybe for a lower level of security, but it gets the job done better than what you have today. And as a result, now we can put quantum advantage into many more places than ever before. Let's step along. So in the end, we envision very shortly this opportunity to migrate from today's TLS to tomorrow's true TLS, where we have all of the components upgraded to quantum readiness, a hybrid certificate that includes classic encryption and post-quantum encryption so that you have the best of both worlds, a post-quantum digital signature, a post-quantum key exchange, a quantum random number as the cryptographic key, and of course, today's gold standard, AES 256, which is deemed quantum resilient, and soon to be other algorithms that continue towards quantum resilience as time marches on. But all of these, the internet was built with TLS to support this kind of ability to evolve the crypto suites, and we now have the opportunity to do that. And when we do, this will field upgrade and enhance an estimated 1 trillion transactions that are happening every day today. We can quantum upgrade the internet. And that is powerful. And it's powerful because it can be delivered through everything like mail, through data traffic, through browsing traffic, through VPN and networking, all the way up to hardware. This slots in. The internet was built on standards and standard protocols. Add a Q to it, and you're cooking with gas. All right, let's go on. And so the necessary and obligatory, since we're sponsoring today's talk about Quantropi and how we fit into this equation. And for us, we took true to heart. We took crypto agility to heart. And as Brian said so eloquently, it's about quantum science. And our quantum advantage and quantum resilience comes from applying quantum science to information security. And just like Einstein, we express quantum state and quantum behaviors through mathematical expressions in linear algebra. And as we all know, as computer scientists, once you've got math, you can derive an algorithm and computer code. And from that, we're able to derive asymmetric encryption, symmetric encryption, and strong random numbers, generation and distribution, those three building blocks of true. And then we're able to package it up into a digital suite, Keyspace, which is a platform that delivers our mask asymmetric suite, keep symmetric suite, and secure random number suite. And I say suite intentionally because it's not one algorithm. It's a suite of algorithms. It's crypto agility. And it's providing the right tool and giving the person leveraging the platform the right, I like to say, Lego blocks, whether they're building a rocket, a castle, or a spaceship. They can build what they need from these primitives, and they can mix and match. Again, that's the beauty of standards and protocols, is that I can combine quantum random numbers from Quantropi with AES 256 from a cloud provider. I can match our digital signature with Crystal Kyber from NIST. And the best part of that is, again, right tool, right job, right application, quantum security. Let's go on to the next slide. Of course, some obligatory speeds and feeds. I will leave it there for the recording and for people to read at their leisure. But what's important is a robust set of primitives, the core cryptographic functions that any application, any network can step into and take advantage of. And because it's digitally delivered, say that 3 times fast, it's available regardless of your operating system, language of choice, CPU, you name it, we can deliver it. That's the power of the internet and IP networks of today. All right, let's go on to the next slide. So all great. How do we use this stuff? How can we get started? How can any organization see themselves and say, where's my first move? And I'm going to ask our moderator to go ahead and put up the poll. So as we go through these examples, you can start to respond to the polling question. But in the end, what we're finding is the deployment of these post-quantum technologies that will protect you from a quantum attack follow the pattern of the last 50 years of IT and network and infrastructure. So it's not some radical departure. It's more, think about the pattern and think about, oh, where do I swap out the pit I haven't had to think about, which is the encryption? How do I swap in the right cipher suite to get what I need today? And also what we're finding is that first movers, when they're testing the technology, taking it for a test drive, getting experienced with it, what they're finding is that the use cases that they can start with are ones where they've got control, or at least very strong influence over both ends of the pipe, right? The handshake between the client and the server, between Alice and Bob in security terms. When you have both ends of the pipe, now you can upgrade both ends and get that full benefit. And so we're seeing folks say, let's do internal use cases, employee partner use cases first, before we worry about John Q Public. Because until my mom's Safari browser is upgraded to a new post-quantum stack, Expedia.com isn't going to be able to do post-quantum security with her. And so when you're dealing with the B2C world, that's going to come later. But what you can do today is protect the crown jewels, protect the enterprise or governmental core. And in doing so, provide the resiliency you need for operations. And then as the internet standards upgrade, as NIST does its process, the masses will come. So I'm going to step you through pretty lightly some of these use cases just to bring them to life, give you a flavor, spark some imagination, and then Brian and I will be glad to answer the questions you might have. So if you go to the next slide, please. So bring your own key. All the major public cloud providers and all the top 10 major SaaS providers, whether you're thinking Salesforce, SAP, ServiceNow, whether you're thinking Google, Amazon, Azure, all of them have this idea of bring your own key or customer managed key, where you can bring in a quantum random number, your own key material, and inject it into the key manager that is used by those cloud services. And in doing so, take complete control of the generation, the distribution, the use of the best keys available in the market. And of course, over time, some of those platforms will offer their own quantum key sources, but the power of this is control and authority and resiliency. And this is something you can literally plug in this afternoon, and in doing so, harden your existing cloud posture long before you start worrying about implementation of new algorithms, because the computer scientists have shown with a strong key, existing classic algorithms work to their fullest security potential. So just upgrading your keys upgrades your security posture immediately. Let's move on. The next one, another place to use strong random numbers is if you're a student down at the hardcore level of symmetric encryption, you know that to preserve the encryption key, there's this idea of an initialization vector, a random number that gets injected so that the packets are secure, but you can stretch out the use of the core symmetric key. This is 100% common in every net router, every core network you imagine using and do use today. So switch it from a local system, classically generated random number to a quantum random number, whether from a QRNG or from a pseudo quantum random number generator, hardware or software generated. And now suddenly, again, instant hardening of your network. And this is just an example showing how if I have enough of this IV, 32 megabits or 32 gigabits per second, I can harden the communications between my mobile device and the base station in a 5G scenario, and between the base station and the core network. And so that's a pretty dynamic pattern, and it's pretty addressable. And again, it's instant gratification. Let's move on. One of the big topics, as I've already commented on and Brian commented on, is quantum key distribution, brand new physics-based infrastructure, very exciting, very much still in early stages of development. We're seeing the first deployments, but it's still got a ways to go before it gets to full-on maturity. And as a result, we can look at a digital bridge, right? The digital technologies that can act as a bridge to that fully quantum physics future. And that's where we look at use cases like digital quantum key distribution. And in particular, a very, very exciting use case is things like satellite-based communications, transcontinental communications, where you've got assets and you want to secure them. It gives you a whole new way to upgrade that security. Let's step along. And by the way, this is happening in the real world. We worked with Deutsche Telekom in the Open QKD lab out of Europe. It's part of a whole EU initiative to test and benchmark, again, to bring real world insight to the readiness of these technologies for the enterprise, for commercial deployments, for trusting and mitigating your risk. And we were really proud to have a chance to work with Deutsche Telekom to benchmark digital QKD as a complementary technology side by side with the photonic QKD, and as a result, offer that hybrid, that quantum and classic, the quantum and digital working together that Brian talked about. We're able to show that that can be deployed in a real world scenario. And with Deutsche Telekom, we authored a paper that was published in IEEE to tell that story. Let's move on. So then we move up out of just keys and start to get into, let's combine all three into true. And a great pattern is, of course, the concept of a VPN, right? We're familiar with that. And the power of a quantum VPN is by dropping in, a VPN server at each end of the pipe. I can create a quantum tunnel. The firewalls, the network protocol in between the sites, classic as all heck, untouched. But the quantum tunnel on the inside gives you that upgrade for data security without completely changing your network settings, and gives you that ability to upgrade in place, to test and learn, to work between two of your offices before you worry about working between one of your offices and a customer, and that again becomes an easily deployed pattern, because almost every IT shop on the planet knows how to deploy an enterprise VPN. Let's go to the next slide. Again, another easy use pattern. Instead of a remote hardware, just a remote desktop, right? Put the VPN client on the workstation, on the cell phone, click the little tab, boom, quantum tunnel established. And again, easy pattern. Users are used to turning on their VPN, so why not make it a quantum VPN? Easy adoption, not a lot of retraining for the user, just click a different toggle button, not too tricky, and therefore you'll get adoption, you'll mitigate risk. Moving on. Of course, there's lots of form factors, hardware and software, and that's the power by working with these technologies and working with the standards that have already been established. We can do this in-flight field upgrade without some radical reinvention of how the world works. Moving on. And let's not forget our friends, the critical infrastructures, right? Let's not forget the billions of devices, and growing by faster than the humans joining the internet are the devices, 11 million a day. They need to be secure too. And in some cases, they haven't been able to run classic encryption because they're too constrained, not enough power, not enough CPU, not enough bandwidth. And so going back to my friend SuperCop, we can add quantum security to these devices if you pick the right algorithm, the right tool for the job, the one that fits in the size of the Ring doorbell, the connected car, which is actually our next slide. And this is why it matters, right? We all envision these smart cars talking to their environment, talking to each other, but the highway safety standards say the communication has to be within 30 milliseconds, because that's 1 meter at 100 kilometers an hour. That's the industry accepted safety margin. And so the quantum upgrade can't slow this down, because we start doing this and then nobody wants that. And so again, understanding the attributes, having that crypto agility, because the right tool is in your toolbox, suddenly your car can't be hacked, your infrastructure can't be hacked, your population, your business is happy and carefree. Let's move along. And it's not just vehicle to infrastructure, but it's on board. I mean, look at all these little dots. These are all the different things on your car. And again, as the car you drive goes to zero trust, quantum encrypting and protecting the data flow between the tire sensor and the car's engine matters, because that's how cars have been hacked. And we don't want to see that. So to wrap it up, bring it home, and get us to Q&A, it's a journey. This isn't wave your magic wand, presto changeo, quantum safe. But we've seen this journey before in the world of IT. We've seen, starting in the early 00s, cloud migration, where you look at your IT inventory, you prioritize, and you start moving apps from prem to cloud, from prem to public cloud or SaaS. We've seen it with digital transformation, where we've reinvented entire business processes to be digital first. Post-quantum cryptography is just going to be that little spark that says, well, let's go back and let's look at that policy administration system from the 90s. It needs to be quantum secure because it's full of contracts and we don't want them getting spoofed. Do I fix it, or do I go to a cutting edge SaaS provider for policy administration that's already done the work to make their new system quantum secure? So I'll just do a data migration and I'll deprecate that technical debt that I've already been carrying for a couple decades. And so I think this is going to be one of the biggest catalysts for IT modernization, transformation, to full-on business benefit, just from this little spark of, a security tweak unleashes huge business potential, huge business agility to go with crypto agility. But it's going to follow the same old playbook, which is start with an innovation team and experiment with quantum compute and quantum security. It's going to come out with a strategy where you prioritize an inventory, and then one potato, two potato, run the factory. We've seen mobile factories, we've seen digital factories, we've seen cloud factories. We're going to see post-quantum factories, but it's going to be all of the above. And that is what's going to lead organizations. And so this one little security catalyst is actually going to have a bigger economic benefit than anything else. And so with that, I'm going to close it out and give us a few minutes for questions. Of course, lots of information we've given you. And of course, Brian's already referenced a number of great resources you can tap into. So we would encourage you to learn more and start to plan your journey to quantum compute and to quantum security.
Thank you very much. What an amazing pair of speakers. I love the quantum VPN, to be honest. I'm just coming out of a big exhibition on smart cities where everything is connected, right? IoT is everywhere. This is the future. We have it already, but it's going to be just in our doorstep. So if we are not secure, and if all our data is going to be everywhere, and that can be broken, what is going to happen with our data? We are at risk. There is a clear danger. We have seen this today. I see a lot of questions out there. Just before I go into the questions, just before closing up, you will have time to go and enjoy the virtual booth from Quantropi. You will be able to go there, download some more information, request more information. So please, after we close the webinar today, spend some minutes on that virtual booth, because Quantropi have put some information, some additional more information for you. Okay, so a lot of questions here. Let's start maybe with the results of the poll. What do you think, Brian, Michael?
Mm-hmm.
Sure.
Good. So thank you, Maninda. The question was, what is your organization's position on incorporating post-quantum cryptography capabilities? Can we see the answers on the screen, Maninda? So I see
The Jeopardy music.
Some people are voting still. So most of votes are going to conceptually interested, but no specific actions taken today, which is good to know. We still have time. It's not too late. And we know now how to do it. So some questions from the audience. We have Pepo Dobrev. He said, a question probably to Brian, but Mike can jump in too. On your slide regarding where quantum tech is right now, still an emerging technology that we have seen boom over the last decade, is there any hypothetical timeline based on adoption?
So, Araceli, that is probably one of the most frequent questions, and I love that question. In fact, over the past 6 days, I spent 22 hours listening to podcasts from various different experts to address this question, because the responses range from we will know in 3 to 5 years what we're going to get in 3 to 5 years, so expanding that out to 6 or 7 years, to in terms of commercial advantage, to some people who are very optimistic that within 3 years we are going to have products that are have commercial advantage, so that things that actually will be viable for those organizations. What I have not heard is 10 or 20 years from now. So I'm hearing more and more from those people who are in the business and delivering on products, being practical about the fact that their products don't do everything today, but realizing that, anywhere from 3 to 6 years from now, they believe that that sort of commercial advantage is going to be available. And again, every technology has incremental, iterative improvements, and that's what we're looking for. We're not looking for the home run. We're looking for those profit potentials that we can get out of the technology on an annual basis.
Just to jump in, Brian, isn't it fair to say also, at least what I've heard, and I defer to you, but I've also heard that it's not also going to be, again, ta-da, all problems solved equally, off you go. It may be that for certain classes of problem, like we saw with where Google already announced quantum supremacy for a particular problem, that some problems may come in and be commercially viable a little sooner and some a little later based on the nature of what you need the quantum computer to do. That's what I've been hearing. Is that fair to see that we'll see different problems be commercially viable at different times? Or
we're already starting to see it with things like Quantum Inspired, where we're using new ideas from the quantum ecosystem, but applied on classical computers. And we're seeing several companies already start to gain real-time results. Then when you start to move into the hybrid capabilities, where you're starting to integrate your classical and your quantum computers, you're starting to see some incremental improvement. I'd say the third category of quantum native or pure quantum is a little bit farther in the distant future. But if you look back at that first stage, we're starting to see results.
Nice.
Thank you. So have you seen, Pepo, I have seen that you elaborate on your question. So decade or two or more, it really depends on what we are talking about, but it's incremental. I agree with that. And I think the very cool thing about all these technologies that we are working on deploying the technology and being ready at the same time that the technology is being developed. And that's pretty new. And we have a clear opportunity there. So Pepo has been working a lot on the question, but Michael and Brian, you are free to answer more in detail some of the questions later on if you want. So Mohammed has said, if a company implements NIST standards with quantum safe algorithms, is it enough or needs to implement QKD or random key generator?
So I'll take the first jump at that, if you don't mind, Michael. Because one of the things that I think we're finding with any standards organization is that they realize that those standards will be usurped over time. That certain standards or encryption schemes will be usurped. If I'm talking to an organization and I'm thinking about them building a fortress around their organization, they want to apply what is value add from those NIST standards, but they also want to be looking at other capabilities to create those walls around their organization within their cost, within their scope and scalability and implementation schemes, for sure. But I think there's more to the story.
Well, and I would jump in and say, what's one of the fundamental philosophies of cybersecurity? Defense in depth, right? If you have multiple different technologies involved synergistically in security, you're more robust because then there isn't one failure point. And so a lot of folks, again, in the industry amongst the different suppliers, because they sometimes think of it as a or. We look at it as an and. To your exact point, Brian, which is I'm going to and the best source of random numbers I can get, because that's the E in true, with the best delivery of trust and QKD right now is on key exchange. So I still need to marry it to an algorithm. So I might use a fantastic photonic QKD solution from, say, ID Quantique with the NIST digital signature with, AES2 or keep from Quantropi, just to plug it, right? Because that's the right mix for me in terms of what I need to get done and what the right price performance is. But the point is now a hacker has to break 3 completely different things in order to get to me. And that's the power, or 4 different things even, right? And that's awesome sauce. And so it's more right tool job, price performance, maturity, but no longer, but unfortunately, security, especially on cryptography, has been fire and forget. Pick a standard, put it in your Outlook server, all your emails done, call me in 10 years. Those days are over.
Interesting. So John is asking, how do you feel the growing global geopolitical divide will impact the quantum ecosystem over the next few years?
So I'll start with that one. We're seeing some standards being driven out of the United States, but there's no reason that other standards can't proliferate. From whether it's the EU or from Asia. And so what any individual organization needs to be thinking about, if we think about our audience here today, there has to be a realization that those standards may evolve and that they need to be aware of those standards and how they implicate the markets that they're included in. The bad agent, bad actor is a whole different topic, but if we're talking about the shield, if we're talking about the protective side, every organization needs to think about possible multiple standards environments.
Oh, and also, look, a little competition never hurts. Look at the Olympics, right? Global competition spurs innovation. Look at capital markets. Global competition spurs it. So there's competition. That's why you saw, like, Hungary has a quantum investment strategy, because it's open field and a little competition. You never know where the cream's going to rise, and that can create tremendous economic opportunity. But then on the security side, again, more minds working on it. Again, NIST has had a global open standard. Japan's doing stuff. China's doing stuff. Again, because the internet itself is designed to be inclusive, the beauty of that is I'll be able to incorporate those regardless almost of where they come from, and within the regulatory environment I operate in. And the net result is I can best of breed it and therefore be secure, or if I'm a business, tap into the compute side, best of breed it and get real business advantage.
Thanks. We have a question from Asvani. He said, how to handle the scenario of an attacker downloading the ciphertext now and break it later with quantum?
Well, I'm going to jump in on that one. Unfortunately, if it's gone, it's gone, right? So I mentioned those email servers. They're sitting in somebody's storage vault. You can't get them back. You can't teleport in and fix them. So that's why you can't wait, because every breach, and Brian, you mentioned some breaches on the number of breaches year to date. Every record that goes out the door today, every email that is sent today, every contract that is signed today remains vulnerable. If it's still your contract or your data and it hasn't breached, good news, you can upgrade it. If it's gone, you're shutting the barn door, but the horse is out.
Joel is asking, can a quantum computer with high fidelity qubits break quantum encryption? Or what would it take to break quantum encryption? Or is that even possible?
Well, I would say nothing's impossible, but the intent, right, of the NIST, of Quantropi and others, and QKD is to come up with schemes for which nobody has yet invented an attack. Doesn't mean they won't. And that's always the conundrum of cryptography, which is people say defend against attack no one's invented yet. You tell me that no one will ever invent an attack ever that breaks your stuff. Okay, that's an interesting philosophical, but it's an absolute that's impossible to achieve. So that's, as Brian first brought it up, and I've hopefully been beating the drum, that's where agility comes in. It's because you're not locked in. You can roll with the punches, and when better comes along, you can roll into it and not have to go through this big monolithic upgrade. The internet has a technical debt because we've let cryptography be fire and forget. And that's why we're kind of coming to a Y2Q style moment. I don't know, Brian, if you agree or have other things you'd say on that.
I would just say that I get the question all the time, and certainty is not part of this business. We will just have to be, aware that things are going to continually change. Maybe a DNA computer will be created in the future, and it'll take quantum out of the equation. There's all sorts of different possibilities. But the one final message I guess I would say is that you must start now.
Thanks. So I'm going to go for the last question of the public today. Richu is asking, could you share a realistic technology timeline for quantum computing to break RSA? How many qubits are required and how much time, days or years, will it take to crack RSA 2048?
So I'll start, Mike, if you want to finish. So this
Sure.
falls into the question of certainty, Araceli. The latest estimates are between 2 and 13 years. And so and 13 being 2035. And so, you look at it and you say, okay, so what does that mean to me as an organization? Can I wait for 13 years or do I risk, all of exposing all the data that Michael talked about? So really the question is, how is your organization looking at that very question that Richu asks, which is a great question, because now what you start to do is thinking about your quantum transformation and thinking digital transformation was 2 to 5 years for any given project. So how long is it going to take me and what risk am I willing to move from that 5 to 13 years?
Right. Because I think that's dead on. And that's why when I talked about the roadmap, that I think the playbook we've seen with other migrations of the last decade or two, you're going to start with what, if it gets compromised, puts me out of business, right? Or crashes my economy or crashes my government. I should start with that one, right? So it's not all day one, boom. No one can do that, but it's going to be rack them and stack them. What's the first one? And knowing that if it gets breached between now and the time I upgraded, it's breached, it's gone. So therefore, it doesn't matter when they can get it. Now, again, if it's only going to be good for 5 minutes because it's a trade, who cares? Don't even bother. But if it's the nuclear codes or stealth bomber plans or compromising photos of Brian as a youth and he's running for president, now suddenly, that's the stuff you can't let out. And so therefore, that's going to set your priority order. And you don't got to do all one time. Do 1, do 2, do 3, ramp yourself up. But just by doing one, as Brian said, getting started today, do the first one, understand what it means to actively manage your encryption schemes and your digital certificates. And that will then help you really scope and understand how big or little this transformation is really going to be for your organization. And now you can put a plan, you can get a budget, you can get board approval, and you can run the factory.
Thanks. So yeah, there's still time, but you need to start now. Otherwise, it's going to be too late. So
Start now.
To wrap up, Michael and Brian, just 30 seconds message to all our listeners. This is going to be recorded, and we're going to share this with all the people who register. So just a key message for all the people who are going to listen to you now or later.
So I'll start, and thank you very much, Araceli, and for the people who are hosting this, for the people who are attending this. Very much my message is that you need to start thinking about those priority assessments of what data is really important, going through that inventory, and then determining what your strategy is and creating a roadmap for that. And again, start now.
Yeah, and I think that's beautiful. It comes down to quantum computing is exciting. It's dynamic. Every day we hear about another breakthrough. And the great news is that's going to have some wonderful business and societal benefits. The flip side is that every one of those breakthroughs brings Y2K that much closer. So roll up your sleeves, do something, big or small, small. Just get the train rolling, get it out of the station, get your organization quantum aware, and the net result is going to be pay dividends on the business side and on the security side.
Thank you. So don't miss the train. Thank you very much, Brian, Michael. Thank you, Quantropi and the Quantum Insider for hosting this together with us, QURECA. And don't forget to visit Quantropi virtual booth in our virtual platform. Thank you very much. And any further questions, please reach out to us anytime. Be ready now before it's too late. Thank you.